communication or even scanning or even sensing. Majorly in this lecture we will learn about nano indentation. So, let us see about that. So, nano indentation is utilized for measuring the mechanical properties of thin films, coatings or even smaller volumes. So, see if you have a microstructure and where the faces are in the nano regime, and if you want to extract what is happening what is the change in the mechanical property because of those particular faces, we need to see what is the property of individual faces. Like we have phase A, so like we have phase A and we have phase B, and assuming that the overall length scale is couple of nanometer. So then once we make a tensile bar specimen, it will give us a property of the bulk. So, we can get a overall property of the bulk using the tensile bar specimen, which can provide us modulus of the system or stress strain relationship. But if we want to see what is happening, what is the contribution from each and every individual phase, like of phase A and phase B, we need to do the nano indentation. So, we can evince or we can extract the properties out of individual phases. Again, if we have a coating, if you have a very thin coating to the order of couple of nanometers or submicron range, it will say if it is very adherent to the substrate. So, we have a substrate and we have a coating, and we want to see what is the response of this coating with respect to the substrate. We might do a tensile bar specimen, tensile bar testing, but we want to see what is the contribution of coating alone. Then it is very hard, because even if we do indentation, a micro indentation, that might actually have some influence from the substrate also, because the coating thickness has to be independent, because if we are the thickness of this coating has to be independent, it has to be thick enough so that we do not see any response from the substrate, but that may not be in reality, that may not occur in reality when we have a submicron size coating on a particular substrate. So, in those cases nano indentation becomes very essential, because if you want to extract the properties, the indent or the depth of the indent should be smaller than at least 7 to 10 times of the entire coating thickness. So, that in that way we can avoid the contribution from the substrate, and we can get properties only with respect to the coating and not the substrate. So, in order to calculate or measure the mechanical properties of thin films or coatings or even smaller volumes, so in this case if we have a phase A and phase B, these are very small volumes, because we are talking about grain size which is to the order of couple of nanometers. So, we can individually go to a particular spot and do the indentation at those particular points. So, what we can get is property property of that individual grain only. Otherwise, micro indentation, what it will do, its size itself is so big that it will basically go on to. So, if we do a micro indent, it might comprise a much bigger regime of indent and we get an average property, whereas nano indentation will give us a local property. Indent, which is micron size, will give us a bulk or a average property. So, that is why it becomes very essential to utilize nano indentation. And nano indentation through instrumented indentation, it means we are consistently measuring the load which is being incurred on a material as well as measuring the indent depth, and that can help us evaluate the hardness as well as the elastic modulus via consistently measuring the force and displacement. Also, we can have a spatial resolution. So, we can also probe the surface using this particular probe tip, and we can also achieve a very good spatial resolution in this case. So, we can measure property which is very nearby, we can measure the properties of the nearby grains. So, that is what is meant by spatial resolution, that is very good spatial resolution. So, we can measure properties from localized regions. So, we can have an array of very fine array of points where we can extract the properties, and we can get very good properties along the each and every pixel as well. So, that will provide us a very good spatial resolution. So, nano indentation is a very essential tool in terms of extracting the properties, mechanical properties of say thin films or coatings or even small volumes using this particular technique via measurement of instrumented indentation. It means we are continuously measuring the load and the displacement, and through this we can also achieve very good spatial resolution. So, nano indentation is nothing but a continuous measurement of force which is to the order of nanonewton to millinewtons.